All right, so the last unit that we are going to do this year is on exponents, and there's a lot of rules you're going to see with exponents. And what I want to point out is that the rules that I'm telling you are only for exponents. Everything that you've learned about whole numbers and negative numbers, all that's still the same. These are just exponent rules, and I'll elaborate on that a little bit more when we get to those problems. So the other thing that I want to say is this is the last unit. All the information that's in this video right here is for the last unit. So you have 2 weeks to learn this information. So I don't want you just to think that watching this video, that you should have it in just a few minutes. You've got 2 weeks that you need to learn these, and you're going to use these in all your other math classes. This is not a unit that just goes away. These little rules just show up in problems. Okay, so really make sure that you know these rules. So the first thing that I want to say is just to recap on what I mean by exponent rules. So if you have this example right here, this is 2 to the power of 4, okay? And so the 4 represents the exponent and it represents the power. The 2 is the base. The 4 tells you how many times the 2 is multiplied by itself. So you see you've got 1, 2, 3, 4 of them here. And then again, it is multiplying, okay? So it works the exact same way with variables. So if you see x to the power of 4, that means that you have 4 x's that you are multiplying times itself, okay? So again, works the exact same way with variables. So the first rule that I want to talk about is the product rule. So if you have x to the power of 3 times x squared, this is sometimes referred to as cubed, and this is referred to as squared. And so, again, anything to the power of 3 is cubed. Anything to the power of 2 is squared. And they're used interchangeably, okay? Just like the word power and exponent, you will see used interchangeably a lot. So x to the power of 3 means that you have 3 x's, and x to the power of 2 means that you have 2 x's. So if you look, you now have 5 x's that you are multiplying times by each other. So x to the power of 3 times x to the power of 2 is x to the power of 5. Now, what would have been a quick way to go about doing that rather than writing it out this long way? And that would be to add the powers. So the rule is whenever you have a product, when you're multiplying, and again, they have to have the same base. So I'm only talking about exponents that have the same base. Is that you add the powers together. So the product rule is that you add the powers together. And again, this only works if you have the same base. Meaning, if I had y cubed times x squared, there's nothing you can do with that, okay, other than you could rewrite it x squared y cubed. But you can't do anything with the powers because they don't have the same base. So let's try a couple of examples. So here, again, we're looking at the bases. These have the same base, and these have the same base. So when I actually multiply them, x to the power of 4 times x to the power of 6 is x to the power of 10. And then y to the power of 2 times y to the power of 9 is y to the power of 11. Again, same thing here. We can only do or multiply or add. Multiply, but we end up adding. That's the trick. Ones that have the same base. Now we have something here. We have a little bit something different here, which I'm going to talk about that in a sec. So x to the power squared times x to the power of 3 is x to the power of 5. Y, this is like saying y to the power of 1. So y to the power of 1 times y to the power of 5 is y to the power of 6. Now, remember the very beginning I said that these rules only apply to exponents. The number rules stay the same. So if you have 9 times 8, that is simply 72. You're not adding them. You are multiplying them. So you're still multiplying numbers together. The adding only deals with the exponents. All right, so now the next rule that we have is the quotient rule, and quotient means to divide. So the quotient rule, if I have x to the power of 5 times x to the power of 2, divided by x to the power of 2, that means I have 5 x's over 2 x's. Well, if you have something, it cancels out. Like if I have 5 over 5, that's equal to 1, right? The 5's cancel out. And so, or 5 divided by 5 is 1. Same thing here with dividing. These x's cancel out, these x's cancel out, leaving us with 3 of them. So you should notice that you have x to the power of 3 here. Well, the rule when you are dividing exponents that have the same base, so again, the base is x here, the rule is that you subtract. And again, you're not really subtracting powers. I mean, you're not subtracting when you divide. It's just a rule what you're doing with the exponents here. All right, so let's do these examples. And again, they have to have the same base. So these have the same base and these have the same base. So that's kind of how I can tell what I'm going to work with here. So x to the power of 6 over x to the power of 3 is x to the power of 3 because 6 minus 3 is 3. And then y to the power of 5 over y to the power of 3 is y to the power of 2. And again, that's because 5 minus 3 is 2. And that's your answer. There's nothing else that you can do with that. All right, here again, we're going to look at exponents. And again, I'm going to highlight the ones that have the same base just so that there's no confusion. All right, so x to the power of 15 over x to the power of 12 is x to the power of 3. Y to the power of 3 over y to the power of 3. 3 minus 3 is 0. Or you can think that these just cancel out. So the y is completely canceled out. And again, just like with multiplying, if I have 12 over 4, that means 12 divided by 4. I'm not subtracting here. I'm actually dividing. The rules for numbers stay the same. So 12 divided by 4 is 3. So the answer here would be 3x cubed. All right, now the next rule is called the power rule. And so the power rule is when you have an exponent, a base to a power, and then it's to another power. So you see that you've got 2 powers going on here. You've got a power here and you've got a power here. So that's what it means by power rule. And so the power rule, if you're looking at this, you notice you've got x squared, but we have it 3 times, right? We've got x squared, but we have it 3 times. Well, when you go back and you count, you should notice that you have 1, 2, 3, 4, 5, 6. Well, 2 times 3 is 6. So the power rule, when you see a power to a power, which with the exponents, you're going to multiply. Okay? So again, let's do this with a couple of examples. We want to make sure that we distribute the exponent that's outside the parentheses to both parts on the inside. And so this becomes x squared times 3 and then y cubed times 3, like this. So you end up with x to the power of 6, y to the power of 9. Again, I'm going to distribute, but it goes to all parts, even that number here. So you're going to have 2 cubed, x squared, and then times 3, and then y to the power of 5 times 3. Because this is like there is a 1 right here, so you can think of it that way as 1 times 3. So this is going to be 2 to the power of 3, x to the power of 6, and y to the power of 15. That's a weird looking 15. And you may be asked to take this a step further and actually simplify. Just kind of depends on the problem, but just in case. 2 cubed means 2 times 2 times 2, which is 8. So 8x to the power of 6, y to the power of 15. All right, next one. So the next rule is the power of a fraction rule. Same idea as before. You just want to make sure you distribute the exponent to both the top and the bottom. So when you do that, you're going to have x squared, and then I got that times 5 here, and then y to the power of 3, and then that's also going to be 5. So this would be x to the power of 10 over y to the power of 15. So again, going to make sure I distribute it, and then we're going to go through the process of simplifying here. So I know there's a lot going on here, but remember, this is like there's 3 to the power of 1, x to the power of 1, and y squared on top, and then x to the power of 2, y to the power of 1 on the bottom. So this is going to give me 3 to the power of 3, x to the power of 3, y to the power of 6, over x to the power of 6, y to the power of 3. And then again, I'm going to keep going because I need to simplify. And again, I'm going to simplify the exponents that have the same base. All right, so I have 3 to the power of 3, which is 27. Then I have x to the power of negative 3, and then y to the power of positive 3. Now, I actually am just getting ready to talk about this. We're going to come back. I'll talk about this in a little bit later, but this is not a good final answer because you can't have a negative exponent. So this one needs a little bit more work, but I'll explain to that what you're going to do with that in a second, okay? So the next rule is the 0 rule, and this is just a rule that you're going to have to memorize, that anything to the power of 0 is 1. Anything. 8 to the power of 0 is 1. Negative 8 to the power of 0 is 1. However, I want you to notice that negative 8 to the power of 0 is negative 1. I know some of you right now are thinking these are the exact same thing. This has the negative 8 in parentheses, so you're saying the number negative 8 to the power of 0 is 1. Negative 8 to the power of 0 is actually taking the 8 to the power of 0 first, which is 1, and then putting a negative in front of it, because this is like saying negative 1 times 8 to the power of 0. And so this is 1, so you have negative 1 times 1. I'm pointing this out because this is a very common error that people mistake. Just make sure you put the negative sign in parentheses, okay? All right, so here, when I look at this, I see x to the power of 0. And because this is equal to 1, you have 8 times 1, which is 8, and then just y cubed, so 8y cubed. Here, because all of this is in parentheses, all of this is like one thing together that's raised to the power of 0, so all of this is equal to 1. That's it. All right, so the negative exponent rule that I was just talking about. So the negative exponent rule is you can't have a negative exponent in your answer. If you have a negative on the top, such as this here, you have to move it to the bottom. If you have a negative on the bottom, like it is here, you have to move it to the top. So the big thing here is if you have a negative exponent, you are going to switch locations. That's probably not the most mathematical way of saying it, but it's the best way I can think about it. So if you have x to the negative 2, you're going to move it down. It was on the top, you're going to put it on the bottom. So now you have 1 over x squared. Here, because that negative 3 is on the top bottom, you're going to move it on the top. So that would give you x to the positive 3 over 1, which of course is just x to the positive 3. Okay, so if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. That's what I mean by switch locate. And do any examples here. So, all right, so let's say we have, let's say we have x to the negative 2, y to the negative 4. So the negative 4 is going to go on top, the negative 2 is going to go on the bottom, so that you end up with y to the power of 4 over x squared. And that's it. They're just changing locations, okay? All right, so then we have fractional exponent rules. And so fractional exponent rules is just like taking the square root and the cube root, but it also involves other numbers besides just 2 and 3. So if you have x to the power of 1/2, that's the same thing as taking the square root. Okay, you just don't put that little 2 on the outside. You just don't put it there. That's the only number. Any other number, 3 and on, you always put the little number outside the radical. But because we're just talking about square root, you don't put it there, okay? So if you have 16 to the power of 1/2, that's the same thing as square root of 16. So it would look like this, which is just simply 4. So because the square root of 16 is 4, that means that 4 times 4 equals 16. That 2 tells you what two numbers multiplied by itself equal the number here. So if we do that with other numbers, if we have x to the power of 1/3, that's the cube root. You do put that 3 there just to show that it's something other than 2. So the cube root, or 8 to the power of 1/3, or the cube root of 8 is equal to 2. Because there's 3 of these here, there's 3 2's here. 2 times 2 times 2 is 8. Back here, we had cube root. That number here was what was on the outside, right? And then this one, if you have x to the power of 2/3, that means the 2 goes on the inside and the 3 goes on the outside. Because if you think, so same thing here. This number is on the outside and that 2 stays on the inside. Okay? Don't forget to email if you have any questions. We want to help.